Alright, so let's talk TripleO and TripleO Heat Templates. So TripleO Heat Templates are what we use to create the heat stack on the undercloud, and it's going to orchestrate the deployment of the overcloud. And the overcloud will be what you actually deploy workloads on with OpenStack. So for TripleO, this is a really important component. It's really important to understand how this all works, and it's often one of the parts that can be the most confusing when starting with TripleO. So what I want to do is just take a look at some of the common things you're going to want to set with TripleO Heat Templates, and I might make a couple of different videos on different things here. But we'll just start out simple with something that everyone's going to want to change. So if you go to the Git repository, you can see on the screen, this is the GitHub version of TripleO Heat Templates. And you can find all the information you want to find about certain templates and how they all come together, what they work with, etc., etc. If you go to this page and just have a look around. But what we're going to do is we're going to go to our terminal here, and we will go to a new tab. So this is my clone of that repo. So we just do a git pull to make sure we're up to date. So it's going to download the latest commits to that repository, and then we can check out the different branches, and then we'll have a look at changing some settings on a deployed overcloud. So we want to git check out the main or master branch, and see that one's behind by 2 commits as well, so we're just pulling those 2 commits so we're up to date. Okay, so one of the first things you're probably going to want to change, and one of the easiest things to change and look at and explain, is probably DNS servers. So if we look at DNS servers, we can see it appears in a few places, but the thing we really want to find is the actual heat template. So if we look at overcloud.j2.yaml, so we can see in this file, we go all the way to the top, that this file contains a parameters section, and the parameters are where the parameter is actually defined. So to be able to use a variable, it needs to be defined somewhere, and that somewhere is the parameters section of a heat template. So whenever we're trying to find what a setting is or whether a setting exists, we're going to be looking in the parameters section first. So let's look for our first occurrence of DNS servers. So we can see that that's here, and that still appears under the parameters section. And this tells us how we can use that parameter. So we can see here by default, it's just sent to an empty array. We've got a bit of a description about it, and we can see the type is a comma delimited list. So if we want to use this, we're going to use a comma delimited list, and that's going to be how we specify those DNS servers. So let's go back to our OpenStack environment. And this is my templates directory, so I'm in home stack templates. And if we just do a quick grep through all the files here to find where I've defined DNS servers, we can see it's in network config.yaml. So if we do network config.yaml, we can see here I've defined one DNS server. But I actually want to add a second DNS server because I have 2. So I've set up a new one in OpenStack, just using Fedora and FreeIPA. And it is at this address. So if we did google.com at 172.20.10.22, we can see we get a response. So that's our second DNS server. So if we want to change that, we now know it's a comma delimited list because we looked at the template. So all we need to do is add a comma and add our second DNS server. But before we do that, we should really manage all of our changes through Git. It's just good practice to be in, and it means that rolling back is easy. So let's go back to our web browser. So this is the project that those templates are a part of. So the first thing we want to do is we want to go to issues, and we want to open up a new issue. I'm going to call it add secondary DNS server. So we're going to add a secondary DNS server to list. DNS server .22. So we'll assign that to myself, and we'll just submit that issue. Okay, so now we've got a new issue created. So let's just create a draft merge request here, and we can see that that's going to be given this name. That's fine, we can have that name, that's fine. We'll just create a merge request. So now that's created a merge request, and it's also created this branch. So let's go back to our Git repo and let's do a Git pull. So we can see that there's a new branch there now. So we do git branch all. We can see that we don't have it here yet. So let's do git checkout -b and we'll check out that branch. So now we're working on that branch. This is where we want to make the change. And if the change is successful, then we'll merge it with the master branch. So let's change our network config YAML file. Now we need to add a comma for a comma delimited list, and then we'll add our second DNS server. Then we're going to git add that file, network config, git commit -m, add secondary DNS server, and we'll just quickly amend that. Because once we merge it, we actually want it to close that issue. So we'll do closes #5 because it's issue number 5. And I mean, we can be a bit more descriptive with our commit messages, but this is just a demo, so we don't care too much. So we're just going to do a git push, and we need to do with this one. So we go back to let's go back to GitLab. We look at our issue. We can see that a commit has now been added to this repo. So now that we've got our commit, we can run our deployment again. So we're going to run our deploy script. If we look in our deploy script, we can see that it includes the file that has that change. So we can run deploy, and that was the deploy function. So it's going to run for some time. So what I will do is I will speed this up so we can watch the deployment, and we will come back at the end. Okay, so that's still running, but one of the other things I want to talk about now that we've looked at a basic use case for how to find where it's defined in a template and then how to find how it's used, let's look at how you can configure services in OpenStack. So one of them that I always configure when I deploy is Nova. I configure things in Nova. So let's have a look at how you would find a similar type setting in Nova and how you would find how that actually translates into Puppet modules and how it's actually applied on the nodes. So if we have a look at something that I've got defined, I'm defining Nova RAM allocation ratio, Nova CPU allocation ratio, and then I have a separate one down here. So we're going to look at all of these and how to find the different types of variables that are defined already in TripleO Heat Templates and how you can apply something that doesn't necessarily have a heat parameter, but it does exist in a Puppet module. So let's start with Nova CPU allocation ratio. So if we go back to our Git repo, we do a search for this one in TripleO Heat Templates. So we can see that's defined in deployment Nova, Nova compute container Puppet YAML. So this is the heat template we're concerned with. Open this one and we'll just look for CPU allocation. So there it is there. So we can see that it's defined under the parameters section again. And this tells us about how we can specify this in our templates. So it's a type number, and by default, it's just 1.0. So we obviously want to increase that. But let's see how it's used in this heat template. So we're going to find the next occurrence of that value. So we can see here that it's used for Nova RAM allocation ratio in this case. So what we can do then is we can take this RAM allocation ratio and we can go find that in the Puppet module to see how it's actually going to be applied. So if we go back and we go to Puppet Nova, and we just search through this repo for RAM underscore allocation underscore ratio, we can see it's defined in the init.pp file. So we have a look in init.pp for RAM allocation. We can see at the very top, it's also got a description of how that can be used within the Puppet module. We can see that if we don't define anything, it's going to get the service default. And then we can see that it's used here as part of the Nova config section under the default section of the INI file for nova.conf. So if we have a look on one of our compute nodes, we'll go to this one. So this is a Dell compute node. And if we just clear the screen and we'll do an egret -r RAM allocation, and we're going to look in var lib config data, puppet generated, nova libvirt, etc, nova, nova.conf. So we can see that it's defined as 1.5 there. And if we go back to have a look at how we've defined it in our heat template, we can see we've defined 1.5. So that's how it gets to be in that config file. That's how it works following it through TripleO Heat Templates, and how it gets translated to a Puppet value, and then Puppet then applies that using Hieradata. So if we go back again to our compute node, we should be able to find RAM allocation in Hieradata as well. So etc Puppet. So we can see that in Hieradata we have a service config for RAM allocation ratio 1.5. So when Puppet runs, it reads the values from Hieradata and then applies that to the config files that Puppet is creating. So then we've also got this other parameter that is controller extra config. So when we have anything extra config, so this will be the role, in this case controller, we could do compute or compute del or anything else we have a role for, we're defining a value in Hieradata. So in this case, we're going to define allow resize to same host. So what we're looking at here is we're actually looking at a Puppet value in the Nova project, in the api.pp file, and then allow resize to same host, and we're defining that as true. If we go to the controller and we do a search for that, we can see that the default is false in the config file, and we're redefining that as true. And again, that's just been defined in Hieradata. So we can see it there. So again, just the same methodology. We just want to find the value we want to set. We want to see where that's used in TripleO Heat Templates. And then we want to check how that's used in the Puppet module. And that way we have a full understanding end to end of how the things we specify in a heat template are then later defined in Hiera values and then configured by Puppet. Okay, so our deployment's still running, but at this stage we can probably go through and find those the DNS servers. They've probably already been set by this stage. So let's have a quick look at that. So first of all, let's just check that controller again, since we already have a window open for it, etcresolve.conf. So there we go. We can already see that has been defined and been configured on our Overcloud. And the other place we'll be able to find that is also in osnet-config. So osnet-config config.yaml, we can see that it's defined there. And if we go back to our director node and we cd into the home directory under config download, under Overcloud, because that's the name of our stack, this is all the playbooks that are being executed right now. So these are the playbooks that are being run, and that's the output from the playbooks that we can see. So here we have a directory called group vars. If we cd into group vars, we have a file for compute del controller. They're the three roles I'm using in my Overcloud. If we vim controller, we can see that these are all the values, the variables that are being provided to those playbooks as they're executed. And we can see under control plane DNS name servers, we now have the extra DNS server defined there. So it's already completed, and just to recap on how we did that, we found where it's defined in the parameters section of the heat template. Then we found where that is used, and we knew it was being assigned to a group variable for Ansible. So we defined it using the comma delimited list that the heat template told us we needed to use for that parameter. Then we made sure that file was included in our deploy command. We rerun the deploy and it re-rendered all of the playbooks and all of the heat values that it needs. And when config download was executed, it downloaded them all and put them into this file. So that's two examples of setting something for the OS, setting something for like DNS servers, but the same could apply for a kernel parameter or NTP servers or anything you want to set for the operating system. And the second example we looked at was how to configure a service. So the same would apply for Keystone, Neutron, Glance, anything you can think of. You can follow the same process to determine what values you can use. Now our deployment's still running, so just for good measure, we'll come back and we'll see how that has completed at the end. But for now, I'll pause the video and we'll loop back at the end and make sure it completes, and we'll have a bit of a recap again. All right, sweet, we're back in action and the deployment has completed. So we've already checked to make sure the settings have been applied for the DNS servers. So let's just go back to our Git repository. And we know this has worked now, so we'll go back to our merge request, which was, yep, that one. So we're going to approve this one, mark it as ready, and we'll merge it. So once it's merged, we go back to the issues. We can see that issue is closed by itself because we put that closes and the issue number in our commit message. So that's it. That's the overview of TripleO Heat Templates. The same methodology we use there can apply to pretty much any setting that you can think of. Just find it in the TripleO Heat Templates. If it doesn't have a parameter defined, check to see whether it's defined in Puppet. If it is defined in Puppet but not in TripleO Heat Templates, you can just use the Hieradata and the extra config per role. So in the next couple of videos, I'll make one on like net configs. So we'll do different net configs for different nodes, and we'll look at how roles data YAML and network data YAML come into play there and how we can change those to alter the outcome of the deployment. Hope that was helpful.